well over 200 billion devices are connected to the internet.
This wouldn't be possible without Wi-Fi technology.
So everything was cabled and wired. It was not an industry standard at the time. It was proprietary technology, and this came from this company called NCR. Victor Hayes, many people consider him as the father of Wi-Fi. So the number of computing devices or computers started increasing. Running wires to everything started becoming expensive, and they started to have a use case for Wi-Fi or wireless, right? Apple, that laptop that they introduced with the inbuilt wireless cards is what that really changed the Wi-Fi industry.
I watched it on YouTube and I saw the people cheering when Steve Jobs took the laptop in his hand and he walks away to show that no wires.
What really triggered the mass adoption of Wi-Fi is smartphones. What took it really to the peak is evolution of IoT devices. Just like water and electricity, we have Wi-Fi, and it's as important as that.
I'm pretty sure that I get mad if I don't have the Wi-Fi.
Whenever I'm home, I hear my 9-year-old daughter shouting, "Hey, I'm lagging, I'm lagging, I'm lagging." That means that the network is slow and it's affecting the game,
Yeah,
right?
that's frustrating for kids.
Absolutely.
So how important it is to test Wi-Fi in order to ensure a smooth customer experience?
Wi-Fi testing is extremely important because if it's not, then you will have a lot of field issues, and that will end up costing you more. Most of the R&D teams are not doing much testing because we do testing only because it is needed. But if there is a way to avoid testing, we want to avoid it.
If I come to you with one Wi-Fi router and if I ask your suggestion, how do I test this? What would you say?
So to answer this question, I think we really need to understand how
Hello everyone, welcome to Weekly WiFi Wisdom podcast series where we talk about Wi-Fi and the tech that surrounds it. I'm your host, Sainath, WLAN QA engineer at Candela Technologies, and today we have our guest, Mr. Sitarama Penumetsa. He has been in various roles in Wi-Fi, ranging from software development, technical marketing, and product management. He is currently serving as CTO at Candela Technologies. He comes with well over 25 years of experience in Wi-Fi industry, and today we would like to hear from him about how Wi-Fi has evolved over the years and how the testing methodologies are adapting to the changing Wi-Fi standards. It's a pleasure to have you on the show, sir. Today we'll be talking about how the standards are evolving. So could you please tell us a little bit about yourself and how did you get into the Wi-Fi industry?
Yeah, so thank you, Sainath. It's great to be here in this session, and hopefully, whatever information that I can share here can be useful to the to people who are interested in this Wi-Fi domain. So, to talk about how I got into Wi-Fi, and when I moved to the US to do my masters, I really had no clue what I wanted to do. So, but for some reason, somehow I got an internship into Cisco, and that got me interested in computer networking. And so when I went back after my internship, I started taking courses in computer networking. And then through that process, I got really interested in this Wi-Fi technology, which was very new at that point in time. I'm talking back in the year 2001, 2002 timeframe, which is at the time where Wi-Fi was still new. So that was a research topic at that time. And as I was looking for research topics for my master's, I found Wi-Fi very fascinating. I started reading some research papers. And then that was my research topic. I took that as the topic that I wanted to see if I can make some improvements to the Mac layer at that time.
Right.
And I published some papers, and that got me really interested in Wi-Fi and started learning more about the technology. And then as I finished my master's and I started looking for jobs, I was lucky enough to get a job as a research engineer in the Wi-Fi field. And I worked at the research labs at Sharp Technologies, where my job was to write patents and do research on Wi-Fi technology and get involved in the standards bodies. And that really got me interested because I was able to actually attend the standards meetings, IEEE meetings, and actually really see how the technology is being built, how it's being standardized, got a chance to meet many experts in the industry, and that got me really interested. And after that, I just started basically sticking to this industry and started to do more and more things there. So.
Awesome. So it looks like you started more on the wired networking and then eventually got into wireless and then research. Yeah, that sounds very exciting. And could you take a look at these images? So I'd like to know if you had any hands-on experience working with any of these devices back in the day, because these are the early devices that came out once the Wi-Fi standards got ratified.
Right. This brings back a lot of memories for me, at least. So, yeah, if you look at that Orinoco card, Lucent Technologies, we used to use that quite a bit. It's probably the size of a modern smartphone, and so that used to be the client adapter. So we used to have these PCMCIA slots in our laptops. This is a huge slot where you insert this card, and this is supposed to be your Wi-Fi station chip. It used to hold the Wi-Fi station chip. And we used to actually have these client utility software, special software that we used to use to program the device to connect to a Wi-Fi network. So these were before the days when Windows was doing the management for your Wi-Fi interface. It was still new, so we used to have a separate interface and software to actually program the station card. But then, yeah, we used to carry these modules everywhere as the station, because laptops did not have inbuilt Wi-Fi radios at that time during the early stages. I think it was Apple that really started that with that particular the laptop that they introduced, and that really changed the Wi-Fi industry. And really, I think that laptop that they introduced with the inbuilt wireless cards is what really brought Wi-Fi to the front line. And many people who are from my generation would remember the very famous basically Steve Jobs presentation where they launched this laptop, and in that presentation Steve Jobs would use a hula hoop to actually show that there are no actual wires, and because people are always used to wires to connect to the internet, and he was actually demonstrating that for the first time we're able to connect to the internet without actually any wires connected to the laptop. And that really set the stage for really Wi-Fi really taking off. So that's one of the pivotal moments. I think this is the Apple base station product. That is one of the very early Wi-Fi routers that came into the industry for residential use. Even before many of the routers that you see here, all these came along. That was one of the very early Wi-Fi routers. I believe they call it like an Apple airport base station or something.
Yeah.
That was actually quite nice. The product was very good. I didn't personally use it, but it was not very successful because it was probably a little bit early to market, and the industry was not really ready. I think it costed around like $200, $250 at that time. Plus, it will only work mostly with the Apple laptops that have the inbuilt Wi-Fi interface.
So only Apple to Apple.
Yes. So that was one of the compatibility issues that they had. Plus, it was very expensive, and so most people. We have to remember that these were the days when people were predominantly using phone cables, POTS lines, DSL, and maybe some Ethernet. And Wi-Fi was like really the backup technology. So no one was wanting to spend that kind of money on buying these devices. That's one of the reasons why it was not like a huge hit, but it did pave the way for many other future routers to come along at a much lower price point. And most of these companies that you see here listed, they all came later making Wi-Fi routers. And this is like a Cisco, I think, Aeronet Wi-Fi enterprise access point. So this was from a company called Aeronet that eventually Cisco acquired. So Cisco was not in the wireless LAN business. Their entry into the wireless LAN business was through the Aeronet acquisition. So there was a company called Aeronet that started making enterprise Wi-Fi access points. And these were all like thick AP standalone access points at that time. One of the very first enterprise-grade access points that were built. So yeah, I definitely remember working with all of these types of devices.
Yeah, that's awesome. And you mentioned the Steve Jobs hula hoop moment, right? I watched it on YouTube, and I saw the people cheering when Steve Jobs took the laptop in his hand and he walks away to show that no wires, right? And that felt pretty fascinating to watch that kind of presentation and people cheering for wireless freedom, right? They are going untethered from the wires, right? Yeah. And today, according to one of the Forbes report, so it says well over 200 billion devices are connected to the internet. So they're all connected to the internet, and connectivity has been like never before today. But back in the day, I don't think that was the case. And we are talking about 11 Mbps data rates. So what what early use cases did Wi-Fi bring to the consumers? Or at least I would like to know how Wi-Fi was used in the early days. What are the common use cases for the legacy standard?
Right. Yeah, interestingly, I think during the early days, there was really no strong use case for Wi-Fi in homes or in enterprise. This was, I'm talking about 1990s, maybe even 1980s, right? Because at that time, as I said, we had DSL, we had phone lines through which we were getting internet connection. And so everything was cabled and wired. And at that time, most homes had probably like one device that connects to the internet, maybe a laptop, maybe a desktop computer, which there was mobility was not even basically a use case at the time, right? So if you look at how Wi-Fi evolved, it really evolved with the WaveLAN days, which is one of the early technologies that came before it was called Wi-Fi. So WaveLAN was, I think it was in the 1980s that it came along, and it was not an industry standard at the time. It was proprietary technology, and this came from this company called NCR, I think. They're in Netherlands. So there was one of the companies in Netherlands that started this whole WaveLAN technology, and they started it mostly for industrial and retail use cases, where you have the shop floors or factories, or you need these basically large retail stores, where running cables and wires is not going to be easy because of high ceilings and all of that, right?
Oh, right.
So that was the natural use case for wireless, because when you build a new warehouse with huge high ceilings and everything, running wires everywhere is a huge problem, right? Because of that, they thought, okay, maybe we can make this wireless, and that was the first real use case for Wi-Fi technology, right? And so NCR and Victor Hayes, who was one of the engineers at NCR, is many people consider him as the father of Wi-Fi, because he was the one who actually took the technology that NCR built. That was in 2.4 gigahertz and 900 megahertz, but it was still proprietary, which means that the base station or the access point and the client device would be from the same vendor, and they would deploy proprietary technology and things like that. But then over a period of time, the team at NCR and Victor and others started realizing that there is some standardization needed, and there is also some strong use cases for Wi-Fi in residential environment and enterprise environment. So they started working on IEEE standards, and then that's how Wi-Fi started coming along in the 1990s, right? So if you look at the residential use case, the early versions of Wi-Fi was really it's experimental, right? It was for the early adopters, people who are engineers who wanted to try Wi-Fi technology. And we talked about the Apple laptop coming out, and that kind of created some demand for this technology, but there was no strong use case because there was only one device, computer in the house, and it was wire, right? Then from the home, it evolved into enterprise. So as enterprises started coming out, office floors and office spaces where you have a lot of computing devices. So the number of computing devices or computers started increasing, and as they started increasing, running wires to everything started becoming expensive, and they started to have a use case for Wi-Fi or wireless, right? And then from then on, a lot of other things happened. Security was a requirement. Lots of other things that happened as Wi-Fi evolved. But that's so. So to kind of summarize, it was mostly industrial use case, and then it came to residential, and then started getting into enterprise. And as standards starting to get evolved, the adoption started to increase. So
right. So as I understand it, initially Wi-Fi was taken to places where wires couldn't go. So they're not actually using Wi-Fi to use the technology, but as a replacement to wired network where they cannot actually deploy.
right.
And you have started your career, I believe. You are there right since from 802.11b, and now we have 802.11be, and you are still in Wi-Fi. So you have seen every phase of Wi-Fi. So if I had to ask you to pick one standard that's groundbreaking, right? It introduced features that pushed the standards to their limits. I mean, groundbreaking features. If I ask you to pick one standard, which standard would you probably pick?
Yeah, I mean, of course, it's hard to pick a particular Wi-Fi standard. They were all, I don't really consider them as standards. They're all extensions to the base standard. So as use cases started getting evolved, the standards starting adding more and more features, right? So if you look at how standards work, even though the people who actually write all the technology within the standards or develop the technology are engineers, but at the end of the day, the standards are all driven by the market requirement and the market demand, right? So if you look at how the market evolved, market always asked for more speed and more bandwidth, more and more speed, faster and faster. When you go to buy a Wi-Fi router in an electronic store, you would always look for 2x, 4x, 8x speed, right? So because that's what the market needed, or at least was asking for, the standards focused on increasing the speed, right, for Wi-Fi. So across the evolution from 11B to 11BE, one of the things that have been constantly there as an undercurrent all through the evolution of all these standards is how can we increase throughput and speed, right? And so how do you increase throughput and speed? There are like 2 or 3 methods that we can use. And the only way you can increase speed is you increase bandwidth or you increase spectral efficiency, right? Which means that the amount of information you would put, try to actually pack into a small amount of bandwidth. That's called spectral efficiency. So you increase the pipe or you actually send more information in the same pipe at a faster rate, right? So there are really 3 main I guess pillars for how you increase the bandwidth for Wi-Fi. One being MIMO, or multiple input, multiple output, where you can actually use multiple transmitter chains and receiver chains to actually essentially double, triple, or quadruple your bandwidth, right? So that's one of the main drivers that has been all through Wi-Fi. We started with this one antenna, we went to 4x4, 8x8, now 16x16, and so on, right? And every time trying to double the bandwidth. The other driver, of course, is bandwidth. And since Wi-Fi being an unlicensed spectrum, we have limited bandwidth, but you can actually use more and more bandwidth. And as 6 gigahertz and other things opened up, it opened up more bandwidth. So we went from 20 megahertz channels to 40 to 80 to 160 to 320 now.
Yeah, now all the way to 320.
320 and so on, right? And then the other, of course, the third area is how can you improve the spectral efficiency, which is you do that using better modulation coding schemes. So you use higher order modulation rates so that you can actually modulate more and more bits per symbol, and that allows you to push more and more information in the same amount of bandwidth. So by playing with these 3 variables, the standards have really tried to increase throughput. But then there are a number of other areas Wi-Fi has been trying to evolve through the standards. So one being security. Security is extremely important. That's what really took Wi-Fi from a residential technology to an enterprise technology, because once you're an enterprise, security becomes really important.
Yeah,
right?
it's critical.
Critical. So through the process of open, through web, WPA, WPA2, now to WPA3, the standards have evolved over a period of time to make security more and more important, right? So,
Awesome. Since we talked about the evolution, we also discussed about how Wi-Fi is not very well deployed in the early stages. Now, in today's world, we can't imagine the world without Wi-Fi. So, what are few products that has led to the mass adoption of Wi-Fi among the consumers? Any key use cases where it really got as a commodity
right
today as we talk about Wi-Fi?
Right. Now, of course, it's a great question. So, I think the thing that started it all was the advent of laptops, right? So, for the first time, computer is not this big bulky machine that is weighing like 20 kgs or whatever, right? It's not this big system anymore. So, for the first time with the advent of laptops, you're able to actually carry an entire computer in your hand. And that really triggered the case for mobility. Until then, no one was thinking that they would actually hold a computer in their hand and walk with it or move with it, right? That was not even there. That was not even considered. Now, with the advent of laptops, that's really enabled it. But I would say laptop enabled Wi-Fi, but really did not contribute to its mass adoption, because always laptops had Ethernet interfaces, right? They have Ethernet ports, wired ports, and so even with laptops, early editions of laptops, Wi-Fi was considered as a backup technology. When you don't have Ethernet connectivity, or you want to sit in the lawn outside on the backyard or something, maybe you want to use Wi-Fi. But when you come inside the house, you still want to plug back to the wire. And still, even to this day, I know people from who are from the little bit older generation, they don't really trust Wi-Fi. They want to connect to the cable, right? So yeah, laptops enabled Wi-Fi, but not really went for the mass adoption. What really triggered the mass adoption of Wi-Fi is smartphones, right? When Steve Jobs put out the first iPhone, again, I mean, Steve Jobs playing a big role in Wi-Fi in many ways than we think. So when the first iPhone came out, and the only way you can connect to the internet using an iPhone is either through Wi-Fi or through cellular interface. And we all know the cellular bandwidth is very expensive, and you get billed by the minute or by the bandwidth that you use. And so that really triggered Wi-Fi as a strong use case, and for the mass adoption of Wi-Fi. And then as smartphones got starting to evolve, Wi-Fi kind of became the primary technology. And still to this day, not many people might know this, but about I would say about 80+% of the internet bandwidth that goes on wireless, that is fixed wireless, is over Wi-Fi. It's not over cellular, right? Cellular carries very little amount of bandwidth when you're talking about fixed wireless use cases. The place where cellular bandwidth is mostly used is in mobile wireless when you're on the road and when you're traveling and so on, right? So Wi-Fi became the predominant way because it provides you a lot of bandwidth. It uses unlicensed spectrum. You don't get billed by the bit and byte, so you have unlimited bandwidth access, and that's really what proliferated Wi-Fi. And then what took it really to the peak is basically the evolution of IoT devices, right? So now that in a typical home, we just don't have a laptop. We now have like 30, 40 devices that are all on Wi-Fi network. You have your thermostat, you have your doorbell, you have your TV, you have your vacuum cleaner, you have your garage door opener, you have your music player, basically your home media gateway, everything, sprinkler system, everything runs on Wi-Fi, right? So because of this mass proliferation of all these devices that run on Wi-Fi, that really took Wi-Fi to the place where it is now in utility. I mean, I think basically just like water and electricity, we have Wi-Fi, and it's as important as that, right? And that's what really took for Wi-Fi to its mass adoption. Yes.
I totally agree with your statement that Wi-Fi has become utility these days, and I'm pretty sure that I get mad if I don't have the Wi-Fi available for me to access the internet. Yeah, so given how important Wi-Fi has become these days and the smart home ecosystem that you are talking about, Wi-Fi has become widespread. So how important it is to test Wi-Fi considering the today's adoption among the consumers? What role does testing play in order to ensure a smooth customer experience?
Right. That's a great question, and I have been in the Wi-Fi test industry for like 20 plus years now, so I've seen the entire evolution of the Wi-Fi test industry. So see, look, we are all engineers and we like to do testing, but if there is a way to avoid testing, we want to avoid it because it's a cost for R&D, right? So when we're developing a product, of course, we want to put all our energy in developing features and the product and marketing it and selling it, and testing is an extra cost, right? So most people actually don't want to do testing. They don't like to do testing. We do testing only because it is needed, and we always try to, like, if you ask, hey, there are 100 features in this product, do I have to test every feature? It will take a long time to test every feature, and your release date might get delayed by one or 2 years, right? So what are you going to test? You're only going to test the use cases that are predominantly used, the way the product is predominantly used. You try to test those use cases. So if you look about how if you consider how Wi-Fi testing evolved over the last like 2 decades, initially people were most of the R&D teams were not doing much testing because, again, Wi-Fi is considered as a backup technology. And if you compare Wi-Fi to cellular, right, the cellular industry that is actually dominated by a number of key companies, large players, like in the US it's AT&T, Verizon, and others, right? So in India it's Airtel, Reliance, and others. So if you look at how the cellular industry works, they have a very strong, what I refer to as basically a testing ecosystem or a testing mindset. Why? Because they are making money with the technology, and when people are paying for using cell phones and technology, they have a certain quality expectation, right?
Correct.
So they have a very strong testing culture because there is an expectation from when it comes to quality in the case of cellular. So I'm paying so much money every month, and if the cellular connection is bad, I can go complain about it, right? So because there is such a high quality expectation, they would always test. In fact, there are many testing companies in the world that made a lot of money and still make a lot of money through cellular test tools. Wi-Fi was not like that early on. When I started my career in the Wi-Fi test industry, we made products in my company that I used to work for as a startup company. We were early to market. We were making these really nice, complicated Wi-Fi test products that were very expensive. But many people did not want to buy it because they didn't want to spend so much money on testing. Even then, Wi-Fi was considered as a backup technology. But as Wi-Fi started picking up and people started using it more and people started spending money on buying Wi-Fi routers. If you look at the Wi-Fi residential industry, the early routers were considered to be very, very cheap because the operators would actually get these routers from some OEMs or ODMs in Asia, and then they would try to they will not do any testing, they will not invest any R&D, and then they would deploy these Wi-Fi routers. They would spend about $5-10 per router when they bought these routers, and they would give these Wi-Fi routers to customers in the homes. And because the quality was not that good, and they didn't really care about that quality, because at that time operators were making all their money on what they called as triple play. They had phone lines that come to the house, like basically landline phones, and they had TV, cable TV, and then they have internet, right? So those are three revenue sources for an operator providing residential, a service provider providing these residential services, right? But over a period of time, you can see that the TV went away. No one watches the traditional TV anymore. It's all OTT. The phone lines went away because we all use cell phones. Then the only thing that is left is internet, right?
Yeah.
So which means that the only source of income for a residential service provider is internet, and which means it's Wi-Fi. And how the internet is consumed, it completely moved from wired to wireless. So now it's suddenly their only source of revenue is Wi-Fi, and which means that customers are paying for the Wi-Fi routers, and so it is important for them to test even more, because most of their customer complaints are coming from Wi-Fi not working. So because of that, the operators had to shift their strategy, and rather than just buying these Wi-Fi routers from someone, not testing them, deploying them, they actually started investing more in the testing. And as a part, they started investing in R&D also. They started building their own Wi-Fi routers, and they started having a very strong test focus. And that's when Wi-Fi testing kind of really picked up. So now we're at a point where Wi-Fi testing is extremely important, and every product that goes out is thoroughly tested, because if it's not, then you will have a lot of field issues, and that will end up costing even more. So one of the things we need to understand in the testing world is if there is a problem with the product, if there's a bug, if it is found during the early stage R&D, and let's assume it cost X, in the later stage of R&D, right before you deploy, the same bug would cost you 10x. To actually find and fix. The same problem, after it is deployed, after it goes to the customer and they find it, then the same problem costs you 100x, right? So to avoid the 100x cost with the problem, you would want to find it when it's 1x, right? And that is during the R&D phase. And so and people found it the hard way, because they did not actually do proper testing, and the cost of X actually became 100x. When they had to find issues in the field every time. Remember that once you deployed a Wi-Fi router, it goes into millions of homes, right?
Absolutely.
And every home has different versions of software, firmware, and every time a customer finds an issue, they call the call center. Someone has to send a truck. So there's what we refer to as a truck roll, right? So someone needs to go on site and then fix the problem. And so that means that there's a technician, you're paying for the technician, you're paying for the vehicle, you're paying for the transportation, and any bug that actually goes from the R&D to the field could cost you a lot more. And the more installations and the more deployment you do, and the more mission critical the technology becomes, the more these problems will happen in the field, and hence the more you need to test in the lab. And so this change in trend over years really started putting more focus on Wi-Fi testing. This is the residential use case, but the enterprise use case is very similar. Right? Even early enterprise deployments were very simple, but now Wi-Fi becoming mission critical in enterprise. Pretty much most of the bandwidth runs on Wi-Fi, and enterprise network scaling to hundreds of Wi-Fi routers and access points. There are so many testing challenges related to scale, quality of experience, and number of other areas that need to be tested. And so all of this needs to be tested in the lab. Again, it's the same problem. If you find a bug in the lab, it costs X. If you go to the field, it costs you 100x, even in the enterprise environment.
Yeah.
So that really puts more focus on Wi-Fi testing. So
yeah, and this totally explains the point of how smartphone adoption has led to the mass adoption of Wi-Fi, because that single device replaced the TVs you talked about, the landlines you talked about, and you also have the internet on smartphone.
Right.
So yeah, and it also totally makes sense how the cost grows linearly or even exponentially at the stages of the product delivery, right? If it's at the customer, it's too tricky. So it's better we always test it and then release it to the end users.
Right.
So in your opinion, how should one approach in testing Wi-Fi? So is there a standard approach, or if I ask you, if I come to you with one Wi-Fi router and if I ask your suggestion, how do I test this? What would you say?
So to answer this question, I think we really need to understand how the life cycle of any technology works. So if you look at Wi-Fi, it's been around for almost, like I would say, 30 plus years now, or 25, 30 years. And so like any other technology, it goes through a technology life cycle, right? So when you start, it's very early stages of R&D. So there are a lot of things that are unknown, right? And it's not it's a highly it's not a mature technology very early on. So when it's not a mature technology, the end user doesn't really understand how to use it. There is no strong inputs coming from the end user, because the technology itself is new. Like, let's assume like 20 years back, if you're using a first Wi-Fi router or a station device, at that time you would really not know how to use it. So early stages of when you have a technology life cycle, the innovation is driven by the engineers who build the product. So if you look at how testing evolved over a period of time, initially, like 20 years ago, people only cared about, the people who were testing Wi-Fi routers were only caring about throughput, because there was no real solid use case for Wi-Fi from a customer's point of view, right? So the only thing the customer would do is they would go to basically, if you want to make a decision to buy a Wi-Fi router, this was 20 years back. The only thing you would do is you would go to an electronic store and see which router says fastest speed, and you buy it, right? Or you go to some form of a forum where you read some article and someone publishes a test report, a benchmarking test report, where they say they compared these 4 or 5 routers and they think this router is the best from the benchmarking test. So that was the only way people made a decision to actually buy Wi-Fi routers at that time. So because of that reason, everyone focused on pure benchmarking of the devices, because they didn't fully understand the use cases. So everyone was trying to get the maximum possible throughput. So people would say, my router will give you 10% more throughput than the other router, right? You don't know why that will be useful. You just do that because that's how you sell your product, right? So early version of testing was purely focusing on benchmarking. So in the testing world, we used to have this RFC called RFC 2544. The whole goal of the RFC is to actually figure out at various packet sizes, when you actually connect into Wi-Fi router, at different packet sizes, when you try to push the maximum amount of data, what is the maximum amount of data you can push through it without any packet loss, right? Which is basically considered as throughput. So now what we would do is we would only run the RFC 2544 benchmark test, and we would measure throughput at different packet sizes, and we'll publish a report. And then we'll compare the 3 or 4 different Wi-Fi routers available and say, this router is giving you the best throughput, and this router is giving less throughput, so you must be buying this one, right? And that is basically how testing was done for early on, right? Remember that these were the days where Wi-Fi routers were only used with 1 or 2 devices in a home. There is a laptop, maybe there's a computer, and the Wi-Fi router is sitting right next to the laptop or the computer in your home office or your living room. So distance was not a problem. Basically, a number of devices connected was not a problem. None of these were problems at that time, right? But as, again, over the last 15, 20 years, everything changed, right? Now you have so many wireless devices, as I mentioned before. You have smartphones, you have IoT devices. Now a typical home is not just 1 or 2 laptops. There are so many different types of devices, different form factors, different sizes and shapes, different standards, and they're all at different locations in the homes. You have your doorbell that's sitting outside your house. There you have the security camera that's sitting in the balcony. And so now you suddenly have so many challenges. First of all, the Wi-Fi router should work with so many different types of devices made by different companies using different chipsets, using different Wi-Fi standards. They're all at different locations in the house. So now suddenly all of these things become huge issues. And so now testing has changed a lot. Now you're talking about how well a router can handle all these devices at various distances and various locations of the house, and how well can it run all these applications. Because previously there were no applications that really tested the bandwidth limitations of Wi-Fi. Like, for example, early on it was you were only doing email. So if you're doing email, then okay, if the email gets delayed by a couple of seconds, it's not a big deal. You would not even notice. But now we're doing Netflix streaming, high definition video streaming. You're doing VR, AR. You're doing like all kinds of other applications that are very require a lot of bandwidth, right? So then, even if the Wi-Fi router is not performing well, even for a few milliseconds or seconds, and if it's dropping some packets, you will actually experience the effect of that. So now it is not about raw throughput. It's about latency. It's about performance. It's about performance over distance. It's about quality of experience. It's about how well you're able to stream your Netflix video when there are 20 other devices connected to the same network. So these are all now testing challenges that we need to really look into when compared to what we did in the past. So testing has evolved from pure lab testing under ideal conditions and benchmarking with test equipment, to now moving into the more realistic environments where you have lots of real devices, real applications, real houses. We do test house testing and so on. And so now it started evolving into making it even much more realistic as the application started evolving. So now Wi-Fi is a very mature technology, right? So now who calls the cards? It's the end user, end customer, because they know how to use it.
Right.
It's not the engineer anymore. The engineer can add 100 features, but if the end user doesn't want it, they don't want it. So at the end of the day, when the technology is very mature, the people who are actually making the decisions are the end customers, right? And that's what the end customer needs. They want their Wi-Fi router to work non-stop all the time, every time, without any application, all applications. Just like any other utility, we expect electricity to be on 24/7. We expect water to be on 24/7 under all conditions, all weather scenarios. They want Wi-Fi to be working 24/7 in all situations, right? And so that really drives, those use cases drive modern day Wi-Fi testing.
That was insightful answer. So you have also mentioned that these days there are lots of variables getting added to the Wi-Fi environment, right? You mentioned about the security cameras that are outside the house, and lots of modern devices that are also getting inside the house, near, far, lots of variables. What are the difficulties that there could be in the testing process in mimicking the realistic behavior as closely as possible? So probably we might solve the distance problem using the programmable attenuators. So are there any few variables that are very tough to replicate in a testing environment?
Yeah, it's a huge problem that being a testing company, we face this problem all the time. So in the good old days, as I mentioned, all we had to do is take a Wi-Fi router, put it inside an RF chamber, use test equipment, which is a box that we make, that we know how it works, and we control everything in the box. And then that box will create the entire environment. So it will create all the Wi-Fi stations, traffic, and all of that, and we are testing. So there are very, very few variables in your testing. The only variable is the Wi-Fi router that you're testing. Everything else is controlled by the test equipment, and everything else is automated. So the testing was very easy, quite automated, and very few challenges at that time, right? Now, as the testing has evolved, as I said, we have a need to test with more real devices and real applications. So now testing becomes a lot more challenging, right? Because you need so many more things that you need to do. For example, you cannot just put the Wi-Fi router inside an RF chamber with a test equipment in a small space, and that's not enough. Now you need a larger space. So space is a problem. So for example, let's say you want to test your Wi-Fi router with 20, 30 devices. It's not enough to test with virtual devices and test equipment anymore. You need to test with real devices. So now you cannot put 20, 30 real devices inside an off chamber. So now you need a screen room, like maybe in like a Faraday cage or something, which is probably the size of this room.
Yeah.
And then you need to put devices at various locations. So space is a problem, right? So now once you put all these devices, how do you connect them and how do you automate the testing? Because every device behaves differently. Every device has its own operating system. So remember, we moved from a box that is going to create 20, 50, 100 devices that we know, we control as test equipment. And now we are handling like all real devices. They're all using various operating systems, various ways they control, and it's very, very hard to manage them and automate them. Automation is a big problem. Managing is a big problem. Let's say you have an Android phone. There's a new Android version that comes, right? And when you install the new Android version, that changes everything, right? And you're trying to automate it a certain way, but then the automation hooks have changed now. The APIs have changed. So now you have to reprogram it, right? So, okay, that's only the device challenge. The devices can go to sleep. In fact, if you look at our labs, we have many devices that actually early on when we were setting up the labs, that the batteries would bulge because they're being constantly powered, right? So now half the devices would get damaged because of the battery bulge issues and heating issues and things like that. So these are all very practical problems. So that's only the device. Now when it comes to the applications, we have to test with real applications, right? So you have to test with Netflix, Zoom, Teams, all kinds of apps we need to test with. Now, how do you automate the testing with all these apps? It's a big challenge. Even if you figure out how to automate them, again, the new software versions will come out and that will break the automation, right? So we have to keep up with all these different types of apps. Not only do we have to keep up with all the devices, we also need to keep up with a lot of the apps that are constantly evolving and changing. And these are the devices I'm talking about, which actually are what I refer to as general purpose devices like laptops, smartphones, and tablets. Now you have these application specific devices, the IoT devices. These are the printers, scanners, medical equipment. These are devices that are built for specific applications, right? And then we have this whole set of IoT devices that actually don't have the compute power to actually run any meaningful tests on them. And they have their own way they behave, and they use different types of chipsets from different companies. So how do you automate and how do you manage these devices? So space, automation, repeatability, controlling these devices, all these are becoming more and more issues that we have to deal with. So as we come up with better and better ways of testing, we also have to deal with all these additional challenges that we face in testing in the modern day.
Yeah, so real devices has their own set of complex and various challenges looks like. Since you are into testing for well over many years, testing, I hope the testing would mostly align with the use cases of the customers. So in your experience, what are the most common use cases that your customers demand for? And what are the kind of tests that you do to address those common use cases?
Yeah. So again, if you look at Wi-Fi, when it comes to use cases, you have many different types of what we refer to as market verticals in which Wi-Fi is deployed. Residential being the most common one in homes. That's where most of the Wi-Fi networks are installed. So in the home, as I said, Wi-Fi is a utility. It needs to constantly work all the time. Most common complaints that we see is when you install a new Wi-Fi router from a new standard, there could be backward compatibility issues. So let's say you went from Wi-Fi 6 router to Wi-Fi 7 router. The thermostat that was connecting fine before with your Wi-Fi router before is now not connecting anymore, right? So that's a challenge. So it needs to seamlessly connect without any issues, and the connection has to be 24/7 on, right? So now, okay, connectivity is an issue, right? The other issue is the use cases. You should be able to take the device, which is mobile, to any corner of the house, and you expect it to work well without any issues.
Roaming is an expert.
Roaming is a problem, and so that's when the houses started becoming bigger, people started realizing that you will not be able to cover the entire house. Especially people are going to all corners of the house. You cannot cover the entire house with one Wi-Fi router. So then we came up with this idea of mesh networks and repeaters, where the repeaters would extend the Wi-Fi coverage across all locations of the house. So now how well the repeaters are working, and how when you're handing off between one node to the other node in the network, how well is the roaming working, as you said. These are all very important. Now we have a lot of delay sensitive bandwidth sensitive applications. Like video streaming and so on. They have to be working constantly. People are doing stock trading at homes. There's a lot of work from home culture. So a lot of video conferencing and meetings are all happening at home. So Wi-Fi needs to constantly work all the time. And one of the more important use cases, more common use cases, is the gaming aspect. So if you look at homes, kids and adults alike do a lot of online gaming. A lot of these modern games are very interactive, and they're online games, and they're very latency sensitive, right? You get a little bit lag. I still whenever I'm in home, I hear my daughter, my 9-year-old daughter, shouting, "Hey, I'm lagging, I'm lagging, I'm lagging," right? So that means that the network is slow and it's affecting the game.
Yeah,
right?
that's frustrating for kids.
For kids, absolutely. So all of these are use cases: distance, quality of experience, making sure streaming is working well, web conferencing, home office scenarios, and all of that. And this is just the residential side of things, right? Now once you get to like enterprise, then they have their own set of challenges, because enterprise deployments are large scale, right? So you have hundreds and hundreds of Wi-Fi routers deployed everywhere. You have many different types of devices that are there. It's the same problem. Like if you look at enterprise IT, 10-15 years ago, enterprise IT was much more simpler, because the devices were issued by the IT person. So if you join a company, they would issue a laptop, right? They would give you a laptop, and they would give you a phone, company phone, to be used, right? But now we have this whole BYOD culture, or bring your own device culture. Many times people bring their smartphones, tablets, devices to work. And what does that mean? The IT guy does not have full control over what is on the network at any given time. So they need to figure out how to properly test. There could always be this new phone that comes out. Suddenly someone brought the phone to the enterprise network, and it crashes the Wi-Fi router, or it takes up too much bandwidth. And now suddenly the IT person needs to worry about that, right? So the diversity of devices and the use cases and applications, these are all things that these are use cases that you need to worry about, absolutely worry about, right? So And then there are many other applications like industrial applications and number of other places where latency could be a big deal, right? Latency is very important. You need to make sure throughput could be important. You have outdoor scenarios in Wi-Fi. You have what we refer to as this MDU scenario, which is a multi-dwell internet scenario, where the modern way Wi-Fi networks are deployed is if you have an apartment complex or a community, rather than like when I rent a house, for example, in an apartment community, the modern method is I don't have to go bring my own Wi-Fi router, right? So just like I have water and electricity, there's already Wi-Fi in the house. Like for example, when you go and rent an apartment, you don't actually go and install your own water pipes. You don't install your own electric wires and all of that. They're already there, right? So the idea is why can't Wi-Fi be like that as its utility, right? So most modern buildings that are being constructed, they are actually building Wi-Fi networks into the building structure itself. And so basically when you go, you just connect to the network. So MDU is a scenario where there is an entire network that's being set up that is shared by many people in the community, and suddenly interference becomes a big problem, interoperability becomes a big problem, coexistence becomes a problem, and then security becomes a big problem. How do you actually take a physical Wi-Fi router and segment it virtually so that people each one has their own virtual network, virtual private network basically, which while you're still using the same physical access point. So security becomes a big issue. And then other use cases are things like parental controls and provisioning of the devices. Now that you have a lot of IoT devices which need to be provisioned, so I should almost have a zero touch provisioning mechanism. So that becomes important. Kids continuously using devices in homes requires parents to put some parental controls or some some restrictions on how much bandwidth they get, or how much time they use the Wi-Fi network. So there's a lot of features that are needed to add it to the Wi-Fi router, which can allow people to set policies based on users, based on roles, based on time, based on many methods. So now you can say, I want my son's laptop or my tablet to have connection to the internet for 1 hour from 8 p.m. to 9 p.m. because that's their internet time, right? And I can set that rule on the Wi-Fi router. And the Wi-Fi router only allows my son's tablet to connect within that 8 p.m. and 9 p.m., right? So these are all various use cases that are driving the new things that are happening this year.
Right. Yeah. Awesome. So I'd like to conclude by knowing your remarks on this question. So Wi-Fi has really evolved in terms of speed, particularly. The Wi-Fi 7 version is called as extremely high throughput, right? And it goes well over 10 gigabits per second and even higher. So I think Wi-Fi has really put some work in there to solve the speed problem. But moving forward, looking into the future, Wi-Fi 8, Wi-Fi 9, or the further standards, what should Wi-Fi really be focusing on? Because I think the probably speed is solved. 10 Gbps is more than enough to run any kind of application for a user. But what should be the next focus? Particularly when Wi-Fi 6 has particularly focused on efficiency, it tried to make the networks more efficient, taking a step back from the speed and focusing on efficiency. What do you think the upcoming standards should really focus on to ensure a good customer experience with the demanding applications that are coming, like even VR? VR is becoming a thing these days.
Right. No, as you said, speed has always been a thing for all the Wi-Fi standards, and it will continue to be like that because people will always like to go faster and faster. But that is not going to be the driving factor because we are already at speeds which are much higher than most applications will need, right? Now, I'm not saying they will not increase the speed in the coming standards. They will, because they're very used to. We are all used to that, and we expect that from the standard. It has to be faster, right? So, but that will take a kind of a backstep a little bit, and the focus will be more on latency because we are running more latency sensitive applications. One thing to remember is high speed does not mean good low latency. Latency could always be an issue, right? So there is more focus on latency, and Wi-Fi, as we know, if you understand the Wi-Fi medium access protocol, we still know that it's highly undeterministic. The way MAC works, Wi-Fi MAC, when compared to the cellular MAC, we don't have deterministic time slots. So that is a problem that needs to be solved, where Wi-Fi can be more deterministic. So that's the use case that they'll continue to look at. And then power is actually a very, very important aspect because more and more devices are compact in nature that connects to the Wi-Fi network. So while they don't need a lot of throughput, they actually need better range, better reliability, and lower power consumption. So that is one of the new things that Wi-Fi standards will work on is how do they actually make Wi-Fi more power efficient, right? So that the small IoT device that has a tiny battery can keep working for days and days non-stop, right? So there will be newer standards where we will deliberately try to use lower data rates and lower transit powers and things like that to actually still keep the range but make it more reliable and more battery efficient. More battery efficient protocols will be designed. Location is another important aspect. Now people want to actually do location analytics and things like that based on Wi-Fi. So Wi-Fi, there are new things that they would focus on. How do you actually pinpoint the location of a particular device inside a house? Now, of course, once we go outside, there is GPS and everything. But once you're inside the house, you need to figure out location tracking so that you can do various things based on that. Let's say you have a pet or some form of a moving object in your house and you want to track it, right? So let's say you have someone at your door who's actually trying to knock on the door. You want to physically and understand where they're located, where your cat is in the house at any given time when you're not in the house. These are all the things that you need to worry about from a location point of view. There is more research in that area. Better analytics. AI, of course, is a huge thing where you really want to use Wi-Fi technology and all the data that Wi-Fi is collecting. One of the things is it's important to understand is Wi-Fi routers are also data collection machines. They're collecting so much data. They're not just providing you Wi-Fi internet access, but it's collecting like lots and lots and lots of data, right? And so that's where AI plays a role again. When there is a huge data, AI plays a role. And so how do you actually use AI to actually better make everything more efficient with Wi-Fi? Location analytics is a big thing. If you look at enterprise environments, just by using the Wi-Fi network, you should be able to tell, let's say you have a coffee shop, for example. You need to be able to tell using the Wi-Fi network in the coffee shop, how many people are coming into the shop, how many people are leaving, what is the average time they're spending, what is the most busiest time of the day. Like between 8 and 9 a.m. is most of the people are coming. How do you know that? Because when the Wi-Fi phone or your smartphone comes into the coffee shop, it is basically sending probes, and the access points will receive the probes. It will identify the MAC addresses and devices and say, okay, based on the probes that I'm getting, a new device came and it stayed from this time to this time and it left at this time. So why is that important? Based on that, you can make your operations more efficient. So if between 8 a.m. and 9 a.m. is the busiest time, you would put more people at the counter, right? If 4 p.m. to 5 p.m. is very slow time, you would reduce the number of people, right? So if you have like a chain of Starbucks, for example, chain of coffee shops, using the entire Wi-Fi network, you can figure out which particular store has the more footfall, more traffic, right? And based on that, you can change. Maybe this store is, maybe the location is wrong. Maybe we don't need to, maybe we need to close this store because we have very less people coming. So it can make various things efficient. Cash registers, lines, how long is the line? How long is the line in the airport, for example? You can use Wi-Fi technology based location analytics and things like that to figure out how many people are in the airport line, right? Just like Google Maps does all the things to actually predict people when you're outside, Wi-Fi can do the same thing inside, right? So these are all various use cases and based on which the standards are evolving to make location analytics, AI, power, handling many different types of devices. All of these things will be in the newer standards.
Absolutely. Yeah, I think these are pretty fascinating insights where you mentioned about gathering useful data in order to make meaningful decisions to even better the experience. Also, the power aspect, I think the IoT devices that you have mentioned, I think that's critical. Yeah, I think these are very useful insights, and thank you for sharing the wealth of knowledge that you have. So that's all, folks. Thank you for taking time till listening to the end of the episode. I hope you found this session useful. And with all the wealthy information that Mr. Sitarama has shared, I request you to stay tuned for upcoming episodes. And if you have any questions to Sitarama, please leave them in the comments below. So like, share, subscribe. Thank you so much for watching.